Chapter 1: Artificial Intelligence. ThinkBot. Jia. Jia, hi. I've been reading about how newborns' brains work in different situations. Can you tell me more about that? ThinkBot. Of course, newborns' brains are fascinating. When it comes to responding to various situations. Jia, that sounds interesting. How do their brains react to things like loud noises? ThinkBot. Newborns' brains are still developing, and they might startle easily in response to loud noises because their nervous systems are sensitive. They throw out their arms and legs and then bring them back in. Jia. Oh, like when they suddenly wake up when there's a loud noise? ThinkBot. Exactly. It's like a built-in alarm system that helps them respond to potential threats in their environment. Jia. That makes sense. What about when they see their parents' faces? ThinkBot. When newborns see their parents' faces, their brains light up with activity. They are naturally drawn to human faces, especially their caregivers. Jia. It's amazing how they're already wired to connect with their parents. How about when they're hungry? ThinkBot. When babies are hungry, their brains release signals, turn their head and open their mouth in search of food. Jia. That makes sense. And what about when they're in new or unfamiliar places? ThinkBot. Being in new places can be a bit overwhelming for newborns. Their brains are still adjusting to the world around them, so unfamiliar environments might make them feel a bit anxious. Jia, thanks. It's really amazing how their brains are working behind the scenes in all these situations. ThinkBot. True. And this is why human brain is so fascinating and way complex than the machines. Jia. Yes. Now I am intrigued to know how our brain is different from machines. ThinkBot. Okay then, let me help you with this as well. Brain versus computer. While computers are incredibly powerful for specific tasks and calculations, the human brain possesses unique capabilities like emotional understanding, creativity, and adaptability that current computer systems can't fully replicate. The brain and computers have distinct strengths and weaknesses, and researchers continue to study and develop AI systems to bridge these gaps. 1. Processing power. Brain. The brain is immensely powerful and parallel in its processing. It can perform a wide range of complex tasks simultaneously, like processing sensory information, emotions, and thoughts. Computer. Computers are capable of incredible processing speed, especially in terms of calculations and data processing. However, their processing is largely sequential, with multiple cores attempting to simulate parallel processing. 2. Learning and adaptation. Brain. The brain has the ability to learn from experiences, adapt to new situations, and improve over time. This is due to its plasticity, allowing it to create and strengthen connections between neurons. Computer. While computers can learn from data using algorithms, they lack the biological adaptability of They require new code or programming for significant changes. 3. Energy efficiency. Brain. The brain is incredibly energy efficient, using a relatively low amount of energy for its complex computations. Computer. Computers, especially high-performance ones, can consume significant amounts of energy in comparison to the brain. 4. Parallel processing. Brain. The brain is naturally wired for parallel processing. Different regions work simultaneously on various tasks like analyzing visual input, processing emotions, and recalling memories. Computer. Parallel processing in computers is achieved through multiple cores, which can perform different tasks concurrently. However, not all tasks can be effectively parallelized. 5. Creativity and intuition. Brain. The brain can generate creative ideas, make intuitive leaps, and find solutions that are not explicitly programmed. Computer. While computers can be programmed to simulate creativity, their output is often based on patterns and data they've learned from. 6. Storage and recall. Brain. The brain stores information in a distributed manner and can retrieve memories based on various cues. It doesn't have a fixed storage location for specific memories. Computer. Computers use hierarchical storage systems with specific locations for data storage and retrieval. 7. Emotional intelligence. Brain. The brain processes emotions and has a deep understanding of human emotional experiences. Computer. Computers can recognize and process emotions through data analysis, but they lack genuine emotional understanding. 8. Size and portability. Brain. The brain is compact and portable within the human body. Computer. Computers are external devices, and while portable, they are not as integrated with the human body. Defining artificial intelligence. These definitions provide a range of perspectives on what artificial intelligence is and how it's understood across different organizations and sources. Merriam-Webster Dictionary. Artificial intelligence is a branch of computer science dealing with the simulation of intelligent behavior in computers. Oxford English Dictionary. The theory and development of computer systems able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and language translation. MIT Technology Review. Artificial intelligence refers to machines that are designed and programmed to think and learn like humans. Encyclopedia Britannica. Artificial intelligence, AI, the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. European Commission. Artificial intelligence, AI, refers to systems that display intelligent behavior by analyzing their environment and taking actions with some degree of autonomy to achieve specific goals. OpenAI. Artificial General Intelligence, AGI, refers to highly autonomous systems that outperform humans at most economically valuable work. Carnegie Mellon University, School of Computer Science. Artificial intelligence involves the creation of computer programs that can perform tasks that would require human intelligence. World Economic Forum. Artificial intelligence is rife with contradictions. It is a powerful tool that is also surprisingly limited in terms of its current capabilities, and while it has the potential to improve human existence, at the same time it threatens to deepen social divides, and put millions of people out of work. While its inner workings are highly technical, the non-technical among us can and should understand the basic principles of how it works and the concerns that it raises. As the influence and impact of AI spread, it will be critical to involve people and experts from the most diverse backgrounds possible in guiding this technology in ways that enhance human capabilities and lead to positive outcomes. Niti Aayog. AI might just be the single largest technology revolution of our lifetime, with the potential to disrupt almost all aspects of human existence. AI is a constellation of technologies that enable machines to act with higher levels of intelligence and emulate the human capabilities of sense, comprehend, and act. HI versus AI. The debate. Human intelligence encompasses a broad range of capabilities including emotional understanding, creativity, common sense reasoning, and adaptability, while artificial intelligence focuses on specialized tasks and data-driven learning. While AI continues to advance, it still falls short in areas that are natural for human intelligence due to the complexity of human cognition and understanding. 1. Origin. Human intelligence. Artificial intelligence. Human intelligence is the result of complex biological processes in the human brain, influenced by genetics, environment, and experiences. Artificial intelligence is created by programming computers with algorithms and data to simulate human-like cognitive functions. 2. Learning and adaptation. Human intelligence. Humans can learn from experiences, make intuitive leaps, and adapt to new situations through a combination of learning, memory, and reasoning. Artificial intelligence. AI systems learn from data and patterns, but their adaptation is primarily based on programming and the quality of data they've been trained on. 3. Emotional understanding. Human intelligence. Humans possess emotional intelligence, understanding not only their own emotions but also the emotions of others. They can express empathy, sympathy, and complex emotional responses. Artificial intelligence. While AI can recognize and respond to emotions through data analysis, it lacks true emotional understanding and empathy. 4. Creativity and innovation. Human intelligence. Humans can generate novel and creative ideas, make connections between seemingly unrelated concepts, and innovate in various domains. Artificial intelligence. AI systems can generate creative outputs based on patterns learned from data, but this creativity is limited by the training data and algorithms. 5. Common sense and context. Human intelligence. Humans possess common sense reasoning and can understand context, making sense of ambiguous situations and understanding nuances in communication. Artificial intelligence. AI struggles with understanding context and common sense reasoning, often producing unexpected or incorrect outputs in situations that humans would easily grasp. 6. Moral and ethical judgment. Human intelligence. Humans make moral and ethical judgments based on a complex interplay of cultural, societal, and personal factors. Artificial intelligence. AI lacks genuine moral reasoning and follows predefined rules or data patterns when making decisions that involve ethical considerations. 7. Adaptability and generalization. Human intelligence. Humans can apply their knowledge and skills across a wide range of tasks and contexts, adapting their understanding to new situations. Artificial intelligence. AI is often specialized and excels at specific tasks for which it has been trained. Generalizing its knowledge to new situations can be challenging. 8. Biological versus digital. Human intelligence. Rooted in biological processes within the brain, human intelligence is a result of evolution over millions of years. Artificial intelligence. AI is a product of human-designed algorithms and data structures, created relatively recently in comparison to human evolution. How AI is different from HI. An interesting activity to demonstrate the difference between human perception and machine perception is the emotion recognition challenge. Let's see who accurately recognize and interpret those emotions. We get to know that humans often incorporate context, body language, and cultural factors when interpreting emotions, whereas machine perception might rely solely on facial features. Humans may detect subtle nuances that machines might miss, like a hint of sadness underlying a smile like in this game. On the other hand, machines might be better at recognizing patterns in large datasets, but humans can better understand complex emotions that may not have straightforward visual cues. This not only highlights the distinctions between human and machine perception but also encourages participants to consider the strengths and limitations of each approach. Types of AI based on capabilities. Types of AI. Narrow AI, General AI, Super AI. 1. Weak AI or Narrow AI. Narrow AI is able to perform a dedicated task with intelligence. The most common and currently available AI is narrow AI in the world of artificial intelligence. It cannot perform beyond its field or limitations, as it is only trained for one specific task. Hence it is also termed as weak AI. Narrow AI can fail in unpredictable ways if it goes beyond its limits. Apple Siri a good example of narrow AI, but it operates with a limited, predefined range of functions. IBM's Watson supercomputer also comes under narrow AI. Examples of narrow AI: playing chess, purchasing suggestions on e-commerce site, self-driving cars, speech recognition, and image recognition. 2. General AI. General AI is a type of intelligence which could perform any intellectual task with efficiency like a human. Currently, there is no such system exist which could come under general AI and can perform any task as perfect as a human. The worldwide researchers are now focused on developing machines with general AI. As systems with general AI are still under research, and it will take lots of efforts and time to develop such systems. 3. Super AI. Super AI is a level of intelligence of systems at which machines could surpass human intelligence. It is an outcome of general AI. Some key characteristics of super AI include the ability to think, to reason, solve the puzzle, make judgments, plan, learn, and communicate by its own. Super AI is still a hypothetical concept of artificial intelligence. Development of such systems in real is still a big challenging task. Artificial intelligence based on functionality. 4 types of AI. 1. Reactive machines. 2. Limited memory machines. 3. Theory of mind machines. 4. Self-awareness machines. 1. Reactive machines. Purely reactive machines are the most basic types of artificial intelligence. Such AI systems do not store memories or past experiences for future actions. These machines only focus on current scenarios and react on it as per possible best action. IBM's Deep Blue system, Google's AlphaGo are examples of reactive machines. 2. Limited memory. Limited memory machines can store past experiences or some data for a short period of time. Self-driving cars are one of the best examples of limited memory systems. These cars can store recent speed of nearby cars, the distance of other cars, speed limit, and other information to navigate the road. 3. Theory of mind. Theory of mind. AI should understand the human emotions, people, beliefs, and be able to interact socially like humans. These types of AI machines is still not developed, but researchers are making lots of efforts and improvement for developing such AI machines. 4. Self-awareness. Self-awareness. AI is the future of artificial intelligence. These machines will be super intelligent and will have their own consciousness, sentiments, and self-awareness. These machines will be smarter than human mind. Self-awareness. AI does not exist in reality still, and it is a hypothetical concept. Vocabulary. 1. Replicate. To copy something exactly. 2. Plasticity. The adaptability of an organism to changes in its environment or differences between its various habitats. 3. Parallel processing. A mode of operation in which a process is split into parts, which are executed simultaneously on different processors attached to the same computer. 4. Explicitly. In a way that is clear and exact. 5. Retrieve. To get something back from the place where it was left or lost. 6. Hierarchical. Arranged according to people's or things' level of importance or relating to. 7. Portable. That can be moved or carried easily. 8. Perspectives. The ability to think about problems and decisions in a reasonable way without exaggerating them. 9. Outperform. To perform better or do better than someone or something. 10. Rife. Very common or frequent. 11. Constellation. A group of stars that forms a pattern and has a name. 12. Data-driven learning. Data-driven learning treats language as data and students as researchers undertaking guided discovery tasks. 13. Novel. New and original, not like anything seen before. 14. Ambiguous. Having more than one possible meaning. 15. Nuances. A very small difference in meaning, feeling, sound, etc. 16. Interplay. The way in which two or more things have an effect on each other. 17. Intellectual. Connected with a person's ability to think in a logical way and to understand things. 18. Hypothetical. Based on situations that have not yet happened, not on facts. 19. Scenarios. One way that things may happen in the future. 20. Self-awareness. The ability to focus on yourself and how your actions, thoughts, or emotions do or don't align with your internal standards. Let's wind up. The brain and computers have distinct strengths and weaknesses, and researchers continue to study and develop AI systems to bridge these gaps. The brain is immensely powerful and parallel in its processing. Machines require new code or programming for significant changes. The brain is naturally wired for parallel processing. Computers use hierarchical storage systems with specific locations for data storage and retrieval. Human intelligence and artificial intelligence can be differentiated based on learning and adaptation, emotional understanding, creativity and innovation, common sense and context, moral and ethical judgment, adaptability and generalization, biological versus digital. Based on their capabilities, AI are of three types: narrow or weak, general, and super. Based on their functionality, AI are of four types: reactive, limited memory, theory of mind, and self-awareness.